Okay, this video is a continuation of 5.1, lesson number 1. So this is video number 2. So it's still evaluate. So we're going to use the same steps we did before, but we're going to add a step first, because if you notice, this is actually a multiplication problem. So the first step is going to be to multiply. And then rewrite and then simplify. Now, if you notice, these are bases with exponents. So we're going to use the exponent rule. I'll put a little refresher over here of that exponent rule. When you're multiplying either variables or could be numbers with exponents, and the bases are the same. These have the same base of x. What you do is you keep the base and add the exponents. We did some of this in chapter 3 and 4, so hopefully you remember that a little. So x squared times x to the third would become x to the fifth. Works if your base is a number. Also, this would become 4 to the 2 plus 3, or 4 to the fifth. So that's what we have going on here. We have a multiplication problem. Base is 64. So we're going to add the exponents. The exponents are fractions. Don't freak out. No big deal. We can add fractions, especially fractions that have a common denominator. So when you're adding fractions that have a common denominator, you add your numerators. 1 plus 4 is 5, and you keep your common denominator. So we've done the multiplication. We had 2 base 64s, now we have 1. So we did the multiplication. So the next step is rewrite. So the base is 3. I'm sorry, the root is 3. The base is 64. And the power, or the flower, becomes the power is 5. Now I went ahead this time and put that 5 right outside here, because again, I'll show you why you don't want to put the 5 in here. I'll show you what 64 to the 5th power is. That number, I'm pretty sure we do not want to do a factor tree on that number. So we definitely want to put that 5 out here. Now I do need to simplify this, so I am going to do a tree on 64. I hope I have enough room for a tree here. I'm going to write small. So whenever it's divisible by 2, I just keep doing my divide by 2, divide by 2. So 2 times 32, 2 times 16, 2 times 8. Okay, my tree's turning sideways now. 2 times 4, and 2 times 2. So the bottom of my tree is 1, 2, 3, 4, 5, 6 2s. So this is the same as, keep those parentheses, keep that exponent, keep your root here. I'm writing 64 as 2 times 2 times 2 times 2 times 2 times 2. 6 of them, right? 1, 2, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Now do your jailbreak. I need groups of 3. There's one group of 3, that 2 breaks out. Another group of 3, that 2 breaks out. So what do I have outside the jail? I have 2 times 2. Jail is empty because everything is circled. So no radical, but I still have those parentheses on the 5th power. Keep going. 2 times 2 is 4. 4 to the 5th power is the same as 4 times 4 times 4 times 4 times 4. Put that in the calculator. You could also put 4 to the 5th power in the calculator, and you get 1024. Okay, same idea on this one. Our base is a variable. It's okay, we know how to do jailbreaks on variables. First step is we're going to do that multiply. So it's going to end up to be y to the 2/3, keep the base, add the exponents, plus y to the 3/8. Uh-oh, not common denominators. It's okay, we can still add them. I'm going to do this addition over on the side here. So when I'm adding fractions, I always have to have a common denominator. Looks like here it's going to be 24, 8 times 3. So to get a 24 here, I have to multiply the top and bottom of this fraction by 8 and multiply the top and bottom of this fraction by 3. So this becomes 16 over 24 plus 9 over 24. Now add your numerators. 16 plus 9 is 25. Keep your denominator. So that is our exponent. So we have y to the 25 over 24. Whoo, those are big numbers. Don't panic though. It ends up to be okay. All right, so we multiplied. Now we need to rewrite. So y is our base. Our root is 24. Our power is 25. So let's write it how we have been writing it. We have been writing that power out here. Now this is one where I'm going to show you we might want to rewrite it the other way. Because I'm thinking if I have one y, there's no way I can find a group of 24. But, so here I'm going to say question mark. So let's try, and sometimes you just have to try and make sure, am I really fully simplified? Let's put that flower or power, whatever you want to call it, on the inside. So now picture I have 25 y's inside here. I don't want to write them all because you can picture in your head, if I have 25 y's and I circle 24 of them, out of the 24 that I circle, 1 is going to make it out alive. And if I had 25 and I circled 24, how many are left in jail? 1. But we got to put that index or that root on there. So this is simplified fully now. Y on the outside, y on the inside, root or index of 24. Okay, the rest is some your turns for you to practice before you do the other practice that goes with this lesson. Do these first in your notes. The answer to this one is 125. When you do B, you should get an answer of 4. When you do C, you should get an answer of 8. And when you do D, you should get an answer of 16. That is it for this video.